Hello everyone, welcome to GoVMlab VMware vSphere Advanced Networking lecture series. In previous lecture, we had discussed about distributed port mirroring capabilities of vSphere Distributed Switch. In this lecture, we are going to learn about another port mirroring capabilities of vSphere Distributed Switch, and that capability is known as remote mirroring source. Now, if you remember in the distributed port mirroring, the packet used to mirror from distributed ports to a destination distributed ports. So your source is distributed port and the packet is also getting mirrored to a distributed port. In remote mirroring source type port mirroring capabilities, the packet gets mirrored from a source distributed ports to a specific uplink ports. So the important point to notice here that the packet is going to mirror from source distributed ports or any of the distributed port to the specific uplink port. So that's where we are going to learn about remote mirroring source port mirroring capabilities of our vSphere distributed switch. So with that, let's get started. As you could see that we are logged into our vCenter server savcsa01.govmlab.local. Now let's go and browse our vCenter server. That's where we do see our data center created named as SA data center. Let's go and browse our data center. Within that data center, we do see a cluster created named as SA cluster. Let's go and browse our cluster. And that's where we do see that we have a 3-node ESXi cluster. And there are a bunch of VMs which are running on that cluster. Before we go and get started with our port mirroring configuration for remote mirroring source capabilities, let's have a quick review of our vSphere networking configuration. So click on networking icon, click here to browse our data center. As you do see that we have a VDS created named as VDS site A. Now click here to browse our VDS. And that's where we do see there are two port groups created on our distributed switch. The first one is DVPG VM network. That's where our VMs are connected to this port group. And the second what we have it is DV uplink port group. That's a well-defined distributed uplink port group. Now click on that switch, click on host, and you do see that there are two ESXi hosts which are added to this distributed switch. And if you click on VMs, you do see that all these 4 VMs are connected to our distributed switch. When you click on networks, that's where we do see our DVPG VM network as a distributed port group. And if you click on uplink port group, that's where you will find DV uplink port group. Now let's click on ports of our distributed switch. And that's where you do see that port 8 to 11 of our distributed switch is consumed as a DV uplink port. And you do see that all of our VMs, all these 4 VMs are consuming from port number 4 to port number 7, as you do see it here. So now this is how our distributed switch configuration looks like. Now let's go and generate the traffic from our VMs. And let's try to do the packet capture on the uplink port before enabling port mirroring session. Because as we discussed that in this particular lecture, we are going to demonstrate you remote mirroring source capabilities of vSphere distributed switch. And in this particular session type or in this particular port mirroring type, the packet would be mirrored from distributed port to a specific uplink port. So now let's do one thing. Let's generate the traffic and let's start doing packet capture on our uplink, and let's see that do we see any kind of packet capturing or do we see any kind of packet getting mirrored on our uplink port without configuring port mirroring session. So now for that, what we're going to do, we are going to use source VM01. So that is the VM, as you do see that. So these are the two VMs what we are going to generate the traffic. And then you do see that source VM01 is running on ESXi02 host and it is connected to DVPG VM network. So click on that virtual machine, click on OK, run the command if config, and let's make a note of our virtual machine IP address. And you do see that our virtual machine IP address is 172.20.10.206. Now let's go back to our vSphere client, click on source VM02, and if you do see that this VM is also running on SA ESXi02 host and it is connected to DVPG VM network. So click on that VM, click on OK, run the command if config, and let's make a note of our source VM02 IP address, and the IP address is 172.20.10.208. Now, we would be generating traffic between source VM01 to source VM02, and we would be capturing the traffic on our uplink port. So now if you do see that, what is that uplink port? Let's figure it out. So let's go back to our network configuration, click on distributed switch, click on ports, and this is the uplink port what we will be interested into. Because if you do see that, the source VM01 would be sending ping traffic to source VM02, and we would want this traffic or this packet to be mirrored on this uplink port, and that port is going to be port number 8, and that's our uplink port. So now let's do one thing. Let's log into our SA ESXi02 host and let's try to do the packet capture on this uplink. Now when we click on this uplink, you do see the respective uplink interface, and that is going to be our VMNIC 1. So let's try to do the packet capture on our SA ESXi02, and let's see that what do we see when we do the packet capture before enabling any port mirroring session. So as you could see that this is what our SA ESXi02 host. So we are logged into our SA ESXi02 host. Now let's run the packet capture command. So we are going to run the command packet capture -- uplink, and that uplink is going to be VMNIC1 as we have just discussed. And we are pretty much interested into ICMP traffic because we are just going to generate ping traffic. So let's filter it out, this traffic only for the ICMP traffic, and let's redirect this output to some file. Let's read it from that file using TCPDUMP utility. This is the command what we are going to run to do the packet capture on our uplink port of SA ESXi02 host. So now press enter key and let's have a look at it. Do we see any packet capturing here? We don't see it as of now because we have not started the traffic. So now let's go and generate the traffic from our virtual machine. So that is our source VM, as you do see that. So that's our source VM, and we are going to do the ping to our destination VM, and that is going to be our destination VM with the IP 208. So let's go to our source VM, run the command ping 172.20.10.208. And as you do see that ping traffic has started successfully, and we do have a network reachability between our source VM01 and source VM02. Now let's look at that packet capture and let's see that do we see any packet capture here? Look at that. We don't see any packet capture here. It's pretty obvious when we have a two VMs connected to same distributed switch running on same ESXi host, the traffic never ever goes to the uplink, right? And that's pretty obvious. But now what we are going to do with the port mirroring capabilities, we want this virtual machine traffic to be captured or mirrored on our uplink port. So now let's go and configure the port mirroring on our distributed switch. So let's go back to our distributed switch, click on configure, and that's where under settings, we do see option called port mirroring. So click on port mirroring, click on new to create a new session. And most importantly, we need to select a session type as remote mirroring source. Now, what does that remote mirroring source? Click on this information icon and you will see that what does remote mirroring source session type does is it actually mirror traffic from a set of distributed ports to a specific uplink ports. So now as you could see that we have a VM which are connected to our distributed port, and we want this particular packet on those ports to be mirrored to a specific uplink port of our distributed switch. And that's what we are going to do it now. So that is the reason we have selected session type is remote mirroring source. So click on that remote mirroring source, click on next. Now let's give a session name. So we are going to give session name as packet. We are going to give session name as mirror traffic from DV port to uplink port. So what we are saying that we are going to create a session which says that we want to mirror traffic of DV port to uplink port. Now the next thing is status. Obviously when we are creating a port mirroring sessions, we want that session to be enabled, and that's the reason we are going to change the status from disabled to enabled. The session type, because we had selected session type as remote mirroring source, so it's well defined here. Encapsulation VLAN ID, let's go with the default VLAN ID 1. And if you want to preserve original VLAN, if you are running a VLAN back traffic, then you can just preserve that original VLAN. Or if you are not running any VLAN specific traffic, then it's okay to not to have preserve original VLAN. Now here, one of the very important thing what we have to see it is normal IO on destination ports. Now what does that mean? It means that do we want mirrored traffic to be allowed in our destination ports or not? By default, if you do see that the normal IO on destination port is disallowed, which means that mirror traffic will always be out on destination ports, but the traffic will not be allowed in destination ports. Because in this particular session type, port mirroring session, we want our distributed port traffic to be sent it over the uplink ports, and that's where we want this mirror traffic to be allowed in our destination ports. And that is the reason we are going to change this configuration to allowed. If you remember in the distributed port mirroring, the previous lecture what we had discussed, there we did not enable normal IO on destination ports because we don't want this mirror traffic to be allowed in our destination ports. At that point of time, the traffic was just mirrored from one source of DB ports to different DB ports, but ultimately it's between DB ports. But here we need to allow IO on destination ports. The next thing is basically the mirror packet length. So it's all about the length of that packet. If you want to define it, by default it's 60 bytes. You can alter the length of mirrored packets. The next thing is basically sampling rate. At what interval do we want this packet to be captured? It's like every one packet out of 5 packets, or every one packet you would like to mirror. So you can define the sampling rate, at what rate we would like these packets to be mirrored. Now click on next. This is the section where we are going to define about the source, like what is going to be our source port for the port mirroring session, as you rightly see it here. So now click on this plus icon and we are going to select the port, our source VM02 ports and our source VM01 port, because this is the traffic what we are interested into. So these two traffic we would like to mirror on our uplink port. So select port number 5 and port number 7 for our VM01 and 02. Click on OK. Now if you do see that, if you want to change the traffic direction, so you do see that by default traffic direction is ingress and egress. If you want to change the traffic direction, that's where we have an option. So this particular option is all about ingress. So as soon as you select that option, the traffic direction gets changed to ingress. If you select this option, the arrow which is pointing towards left, the direction changes to egress. So that's how you can actually change the traffic direction from ingress, egress, or maybe both ingress and egress. So let's go with the default traffic direction, ingress and egress. Click on next, and now look at that. In remote mirroring source, it doesn't ask for destination port of our distributed switch, because as we have discussed many times, in remote mirroring source we are going to mirror the packet to the uplink port of our distributed switch, and that's where it is asking us to select that uplink port where we would like our packet to be mirrored, and that's where we are going to select uplink port as uplink 1. And if you remember, that uplink 1 is our VMNIC 1. So click on add, click on next. Now before I click on finish, let me quickly show you our ESXi host, and if you do see that till now we don't see any packet on our uplink port. So now let's go and click on finish, and we'll do see that a new port mirroring session has been created successfully. So as you do see that is our session name, mirroring DB port traffic to our uplink port. The source, the session type is remote mirroring source, as you rightly see it here, and the status has to be enabled. That's another very important point. If you create a port mirroring session and the status remains to be disabled, then obviously the mirror functionality will not work. So we'll have to make sure that the status is enabled. Now click on that session name and you will find all the details right here about our session properties. If you click on sources, that's where it will give us information about the source VM and the port traffic which is going to be mirrored, and that is the destination where the traffic is going to get mirrored. That's a uplink. So now let's go back to our ESXi host and let's see that do we see any packet capture, and look at that. We started seeing packet capture as soon as we enable that port mirroring session. And if you do see that, we do see ICMP echo request. So if you do see that, this is our ICMP echo request from 10.206 to 10.208, and we do see ICMP echo reply from 208 to 206. So now it clearly tells us that as soon as we enable the port mirroring session, the traffic is start getting mirrored between these two virtual machine DV ports to our uplink ports, and that's where we do see a traffic is continuously being mirrored to our uplink ports, as you do see that. Now what if I go and disable that port mirroring session? So now click on that session, click on edit, and now let's try to disable it. Click on OK, and as you do see that the session has been disabled now. So now let's go back to our ESXi host and look at that. We don't see those ICMP echo request and echo reply anymore in our packet capture, because our port mirroring session is in disabled state. Now, as soon as we go and enable that session once again, we will start seeing the packet capture on our uplink ports, and look at that. Do you see that? As soon as we enable packet capture, we started seeing ICMP echo request and echo reply. So now this conclude our lecture on port mirroring capabilities of our vSphere distributed switch, where we have learned about remote mirroring source session type of our port mirroring capabilities, and we have learned that how could we go and monitor, how could we go and mirror our virtual machine DV ports traffic to a specific uplink port of that same host, and we can start using that packet capture for our traffic analysis, monitoring, or debugging purpose. So this concludes our lecture on port mirroring capabilities of our vSphere distributed switch.